In this video, we want to talk about how to solve so-called liquid mixture problems. So this is the application of linear equations. So let's take a look at a specific example how we solve a problem like this. How many gallons of 3% salt solution must be mixed with 50 gallons of 7% of solutions to obtain a 5% of solution? So let's take a look because we want to know how many gallons of 3% salt solution must be mixed. Okay, so we're going to say X. As always, we're going to say X equals the amount of 3% salt solution. Okay. So before we actually set up equation, we want to know what is the rule or the principles to set up equation for this kind of problem. So the main rule is this. The total amount of salt before mixing and the amount of salt after mixing must be equal. Okay, so here you mix two different kinds of solutions. So, and you want to find out the total amount of salt in these two kinds of solution. And then you want to find the amount of the salt in the mixture. So that's amount of salt before mixing and after mixing must be same. Okay, so let's take a look here. Suppose you have here is in 3%, this is 3% the salt solution. And so here you have, okay, this is 7% salt solution. Okay, so we know, okay, according to this here, we say this is X gallons. So this is X gallons here, which is X gallons. And but this says 50 gallons for 7%. So 50 gallons here, this is 50 gallons. Okay, so here now let's figure out the amount of salt in each of this solution. And the 3%, we refer this as a concentration. So the volume times the concentration there, that equals the total amount of the salt. Okay, so that means X times 3%, that gives you the amount of salt in that solution. Amount of salt in that solution also give us use the volume times the concentration. So that's give you the amount of salt in that solution. Okay, so now let's take a look at the mixture. Mix these two together. So because you get X gallons of 3% solution plus the 50 gallons of the 7% of solution. So now the total volume for this mixture, okay, for the liquid mixture is this here, X gallons plus 50 gallons. And we know it is 5%. So that is 5%. So remember, this amount of salt from this mixture is X plus 50 times 5%. According to the rule there, the total amount of salt before mixing and the total amount of salt after mixing should be same. So we already figured out the amount of salt from each solutions. So we add the total amount together. That is the total amount from the two solutions. And should be equals the amount of salt in the mixture. Okay, so now you can see we have a linear equation there. To solve this linear equation, we need multiply 100 to each of this term to get rid of the percent sign there. So here we multiply 100 to the equation. Okay, so 100 times this 3%, which is 3. So I have 3x. 100 times 7%, that's 7. 7 times 50 times 7. And 100 times that's 5%, that's going to be 5. So here you have x plus 50 times 5. So all I need to do is just simplify this equation. I got 3x plus 350. And let's do the distribution. So 5x plus 5 times 50. Okay. So now let's go ahead to subtract 3x from both sides. And also subtract 250 from both sides. So you can see here 5 minus 3, which is 2x. 250 minus 250 is 0. 3x minus 3x is 0. 350 minus 250, which is 100. So both sides divided by 2, so here I have 50. So now you can see that's 50. X is 50 gallons of the 3% of solution. So let's take a look. We check. So here with 3 times, okay, 3% times 50 plus 50 times 7%. So that's give us an 1.5 plus and 3.5. So that's give us 5. Okay, so that give us 5 pound of the salt there. And so now the mixture, so here you have 50 plus 50 times 5%. This is 100. 100 times 5%, which equals 5. So that means that's before mixing, you have a 5 pound of salt solution. After, you still get a 5 pound the salt there. Okay, so that check this the solution there. So now we're gonna answer. We're gonna say, and 5 gallons of salt solution must be used. Okay, so that's what we have for the liquid mixture problem. Always remember the total amount of salt for each, okay, for all those different kind of solutions, and together must be the, after you mix them together, the total amount of salt. So if it's not salt, you can just say the total amount of a chemical before mixing equals the total amount of a chemical after mixing. Okay, so that's for the first problem. Let's look at second problem. That second problem actually is very useful practically. So here, see in this, now we talk about a pandemic. Sometimes you want to use rubbing alcohol, but you find you do not have the 70% of rubbing alcohol. You only get 91% of rubbing alcohol. How are you gonna, okay, add water to dilute? That's 90% rubbing alcohol to 70% rubbing alcohol. Okay, so let's take a look here. And how much water must be added? So you say a nurse wants to add water to 16 ounces of 91% rubbing alcohol to dilute it to 70% rubbing alcohol. How much water must she add? Okay, so take a look at this. I got this rubbing alcohol. This is a 16 ounce rubbing alcohol I purchased from a store. So it's 91%. But 91% of rubbing alcohol and is not as effective as 70% of rubbing alcohol to kill the virus. Okay, so we have to dilute this to 70% rubbing alcohol. That's how we're going to do it. How much water we must add. Okay, so we're going to say X is the amount of the water. Okay, must be added. Okay, so now same thing here. And what you have here, you have two kind of things there you want to mix it together. This is water. This is 91% the rubbing alcohol. And so here, rubbing alcohol, so you have 16 ounces. Okay, that's 16 ounces. That's actually fluid ounce, which is volume actually. And that's water. So here we don't know. We say this is the X. And now after you add them together, okay, so here the total volume is going to be 16 plus X. That is the volume of the mixture. Okay, which means that now it becomes 70% of the rubbing alcohol. Okay, so now water. Water means you don't have any rubbing alcohol in the water there. So that means its concentration going to be 0% for this case. So as we mentioned earlier, so here total amount of chemical, which in this case is the rubbing alcohol, is the alcohol part. Okay, and should before mixing and after mixing must be equal. So from this, okay, 91% of rubbing alcohol, the total amount of alcohol in there is 16 times 91%. This is the total amount of the alcohol, the pure alcohol. But that one is X times 0%. No rubbing alcohol, no any alcohol in there. And after you add water, so that's diluted. Okay, solution should be 70%. So the total amount of the alcohol, the pure alcohol, is going to be 16 plus X times 70%. So that is the total amount of alcohol before mixing. That's the total amount alcohol after mixing. That's two must be equal. Must be equal. Okay, must be equal. So that's the kind of a problem if you took the chemistry class, or you are going to take a chemistry class, you will find that's actually going to use to solve some chemistry problems there. Okay, so now you have this equations, linear equation, same as before. All you need, just go ahead to solve this equation, same as before. You multiply 100 to both sides and to the equation. And so multiply 100 to this, you're going to have 16 times 91. The percent signs reduced, canceled. That one is 0 anyway, so here we just don't need to write anything. Multiply 100 to this term, so here you reduce the 100 with the percent sign, so here you actually have 16 plus x times 70. Okay, so here go ahead to simplify, and so here that's what you have, 16 times 70 and plus 70 times x, and this is 16 times 91. Okay, so here subtract 16 times 70. So you're gonna have this here, 16 times 91 minus 16 times 70 equals 70x. And so here you can see, you can figure out this number, 1691 minus 1670. So, okay, so here you can write 1691 minus 70. You can do this way, or you just point your calculator, it doesn't matter much. So get a 70x. So now you can see here, I have a 16 times 21, 91 minus 70 is 21 equals 70x, and both sides divide by 70. And I find, so here, I got this one equals 4.8. So that means that's 4.8 ounces water you add to the 16 ounces of 91% of rubbing alcohol. So you're gonna get 70% of rubbing alcohol. Okay, so look here. When you talked about fluid ounces here, so the 16 ounce basically is 2 cup. 16 ounce is 2 cup. So the 4.8 ounce, which is in 4.8, and which is 1 cup is 8 ounces. So here, that give us 0.6. So here 4.8 ounces get 0.6 cups. 0.6 cup of water added to the rubbing alcohol, 91 rubbing alcohol, you're gonna get 70%. Of course, if you have a good measure, like a cup or something, you can measure 0.6 cup, which is 3/5 cup. Unfortunately, when you do that at home, possibly you cannot get 0.6 cup, but it just roughly, okay, roughly that's going to be 0.6 cup there. Okay, so now we're going to say, and 4.8 and cup, okay, that's ounces, fluid ounce. Okay, water must be added. Okay, so that's the end of this video.